All right. Here it again is what you just need to understand before I go into. It's a recognizing when to use second fundamental theorem, and I'm going to show you how to recognize it right now. If you notice, first things first, I'm switching with x's and t's. Do you see that? X's and t's? Like, this is weird, Mrs. Seta. And that's literally what's going to happen, and you'll know to use the second fundamental theorem because you'll have this mixture of x's with t's, okay? You'll know that there'll be an area, an integral here. A is a constant. Can you tell me what that means? What does A being a constant mean?
It doesn't change.
It doesn't change. It's a number. 5, 2, 0, -3. So if that bottom number, listen, if the bottom of an integral is a 2, or a 5, or a -12, or you could even have a pi over 4, don't freak out, pi over 4, then, and you've got t's here and an x there, oh, I probably got to use second fundamental theorem, okay? Now, what does the second fundamental theorem actually tell you? Well, this part right here is telling you what to do. It is saying that the derivative of this is as easy as taking that x and plugging it right in. That's it. Literally taking an x and plugging it in. As long as that's x and as long as that's a. Well, what if it was an x, Mrs. Setter? Because this is literally what you're doing. I'm telling you right now, you're just going to go like that. And that's what you're going to end up with. Well, what if it wasn't? Notice how they changed it to g of x? Like they changed to a function? Didn't they still plug it in to the f? And then what did they attach? Which is the derivative of g. So we have to go back to that derivative stuff, okay? So all that to say, I just tried to simplify it. Don't freak out. Let's do an example. Even if you're like, I don't get it at all, let's do an example. It's going to make it easy when we see an example doing. So let me write out the first couple examples. We're going to find capital F prime of x, given that f of x equals the integral from 2 to x, that's a 2, of, 3t squared plus 4t dt. I'm going to write 3 of them right down here. Don't freak out. We're going to do all 3 so it'll make more sense.
Do we need a lot of space?
Nope. Don't need a lot of space on these at all. Next one, the next 2 you do, but then we're done. Not a lot of space, I should say. And I'll tell you, when I taught this in AP Calculus, because they would always throw one of these on the AP test. And again, it was always a multiple choice, and it was always like just recognizing that, oh, I'm just doing second fundamental, which is literally just plugging in a value, an x. Like listen, I know because I wanted you to freak out, but once you see it, you're like, that's not hard, okay?
How much harder is AP Cal than this, or is it easy?
Way harder. Yeah, you have to pass the test with a 4 or 5 in order for it to even transfer.
Yeah.
And to pass it with a 4 or 5 is hard. See, here you only have to pass with a C.
Let's go. Is that a common?
I mean, and it doesn't even, when you go to, let's say, you know, UNCC, it doesn't even transfer over as your grade. It just transfers. So it's like, oh, I get 3 credits, yay, you know? So as opposed to, or 4 credits, actually, I think this is.
Would you help us justify like this class, like in because I remember you said that you would have to be on the phone in order to tell them.
No, I don't know. I can't be on the phone. You have to be on the phone. You have to talk to your transfer coordinator, and you have to say, this class with this course description, which we're taking right now, brief calculus, matches this class with this course description, and make sure that transfer's coordinator is like, yeah, you're right, it does, okay? That I will tell you if you want me to help you out,
Yes,
I will do that for you and show you which one it is, which I've done with many students. All right, so here we go. Here's all you're doing. I'm seeing X's, but then I'm seeing T's and a capital F. Oh, this must be second fundamental. What do I have to do? Is this constant?
Yeah.
That's a 2, right?
Yeah.
If this is an X, then all you have to do is plug it in everywhere you see a T. What would this be equal to? 3x squared plus 4x. That is the derivative of the function Dunsey. That's literally all you have to do.
So how is this like
So what is
after?
Yeah. So it's sine.
It's going to be in Calc 2. So it's relating an integral area to its derivative. That's what it's relating. Okay?
Yeah.
All right, ready? Now watch this, okay? What is the 2? Now listen, no, it's going, guys, look, it's a formula. The formula says if the A is constant. Was this a constant?
Yes.
Yeah.
So where does it go? It doesn't go anywhere as long as A could have been 50. A could have been 5,901.
Or pounds.
But as long, if that's an X, then you just put the X right there and there. Okay? All right, let's do another one. Watch. Is this constant?
Yeah.
It is. Doesn't matter. What am I going to do with that?
Plug it in.
Plug it in. But do you notice that it's not just X, it's X what? Cubed.
3 sine.
So I'm going to have to multiply by the chain derivative. So my answer is going to be, watch, sine, instead of t, you're going to replace it with what? X cubed. So there's that. But you're going to have to attach, multiply by the chain, the derivative of x cubed, which is? And then I would just kind of rewrite it like this. I like my 3x squared in the front. Sine x cubed. That is the derivative of f. Okay? Let's do one more. What if they wrote it like this, Mrs. Seta? What if they wrote h of t? Again, what you're noticing is x's, t's mixed together.
Yeah.
But they didn't really give me a function. That's okay. We still know what we should do with this 4x. What should we do with that 4x? Put it right there, right? So it would be the h of 4x, but it's not just 4x. It is 4x. It's not just an x. So what do I have to multiply by? Which would be what?
4.
So I'm going to put it in front, though, because you always want to put it in front. You don't want to put it in the back, because it's the h of this times 4. And that would be the derivative of x. So again, half your battle tonight is just, oh, wait a second. Constant x, a constant x, constant. I just plug it in, I just plug it in, I just plug it in. Okay? But it will get a little bit complicated with the next 2 problems, but it's still not terrible. Still think you could be able to do it. 2 more and we're done. Okay. F of x equals the integral from negative x to x of 5t dt. And then the last one, f of x equals the integral from 2x, 3x of t squared minus t dt. These are the last 2 we'll do. Again, your job is to notice this is not.
They're not constant.
Oh, I noticed they weren't constants. Good job. That's the first thing you should notice. Do you notice that the bottom is not a constant?
I did.
Yeah, it's really bad.
Man, what am I going to do then? Don't worry. Okay, I'm going to help you out. There was a rule that we learned, a property of integrals. Okay? And the property went like this. It said, you can write this on the side if you want. If I go from a to c of an integral and I add it to a c to b, isn't that the same as just those 2?
Yeah.
So it's called like you break it apart, you take this and break it apart. I'm going to do that to here. Okay? So I'm going to try to figure out some like in-between number. So probably the best to go, if you have a negative x to an x, like a negative 100 to a 100, go to 0. Okay? So I'm going to write this as 2 separate integrals. I'm going to go like this. Negative x to 0. And then I'm going to just keep everything else. 5t dt plus my other one would though go what to what? 0 to x 5t dt. Okay? Now, this one, well, that's in the form that we were just doing on the front page, right? That's a constant. Take that x, plug it in. What are you going to get? 5x. Done with that one. Okay? But we got to add it to this one. Now, here's another problem with this one. Are you ready? Negative x to 0. Isn't the bottom is not supposed, you have to have a, look at the formula. Aren't you supposed to have a constant on the bottom? So I can flip it.
Flip that front upside down.
Okay, so let me flip this. And so again, if you don't remember that rule, it says like if you have A and B, or actually I think it was BA, let me take it back, BA, then you can take out a negative and flip them. Okay, so I'm going to go negative, flip, 5t dt. Okay, and now I can take my negative x and plug it in, and what would I get? Negative x. But here's the problem. I made this mistake in the other class. What should I multiply by? Because it's a chain, because it's not just an x. Boo. But then what do I also have on the outside? Another negative to multiply by. So I've got 3 negatives. So that's okay. What do 3 negatives make when multiplied? So what's negative 5x plus 5x? Wow, that was really exciting to get a 0. Exactly. But that's exactly what happened. We're going to do another one if you didn't understand this one. But the deal is you're going to pretty much be doing the same. You're going to separate it into 2 integrals. You're going to make sure you flip that first one so the constant is on the bottom, because that's what the second fundamental theorem of calculus says.
Let me try something quick. For the next one.
Okay.
Do you back there?
No. Good try, though. You don't even have, no, it's as easy as the one before it. Okay? All right, here we go. What number can go between 2x and 3x? It doesn't matter. I like 0. Why 0? Because 0 is easy. Just pick 0. So we're going to rewrite this as 2x to 0 of t squared minus t dt plus, what would I write my other integral? 0 to 3x of t squared minus t dt. Okay? Now, this one is obviously easy to do. You're going to take 3x, you're going to plug it in here, and you're going to plug it in here. Let's see if we can do it in our heads. What is 3x, though, the whole thing squared? 9x squared. What's 3x minus 3x? But what do I have to multiply that by? 3, because that's the chain. And then what does that become? Okay, so you figured out this one. That one's pretty easy to do because it's already fitting the form of the second fundamental. The form being that there's a constant on the bottom, an x on the top. Okay? Is there a constant on the bottom, x on the top? No. So let's flip it. Okay? So in order to flip it, I got to take out a negative. Now I'm going to flip it. Rewrite everything the same. And take your top 2x and plug it in everywhere you see a t. And don't forget to multiply by that chain. So 2x squared, 2x times 2x is 4x squared, minus 2x times what's chain? Times 2 times the negative on the outside.
2x.
2x squared. 2x times 2x is 4x squared.
Yes, okay.
Okay?
Sorry.
Then 2x is here. Okay, that's all right.
Did you multiply the negative?
It doesn't matter. I kind of, in my head, I just do -2 is what I do. So I would get negative 8x squared plus 4x. Then don't forget to add this over here.
Wait, hold on, wait.
Oh, let's go.
And so what's my final answer?
19x squared minus 5x.
That is the big derivative of capital F right there. Now listen to me. You have another worksheet just to kind of quickly do that. It's 12 problems. Watch, look. You're not going to freak out because it's not going to be hard. Look. It's, again, about you recognizing it. Watch, watch, watch. Okay? Constant x, constant x, constant x, constant x, constant x, constant x, constant x. What am I doing with all of those? You're just plugging in x everywhere you see a done. All of them. You could do that right now. Plug an x, plug an x, plug an x, plug an x, everywhere you see a t. But then, what am I going to do at 8? Because there's a constant, but what do I do with the 2x? Plug it in and multiply by 2, the chain. What about here? There's a constant, but I have a 3x. What do I do? Plug it in, but multiply by the chain. -1, but there's an x squared. Plug it in, but multiply by the chain. What is the chain of this, by the way? 2x. But then what do I have to do for these last two? What we were just doing here. Those last two are like this, okay? That's it. That's all you have to do. And that's the second.